Hello, everyone. Zach here. I just wanted to preface this with a little bit of context as to what's going on. So, Logan's playing Borderlands pre-sequel, and it piques the topic of theoretical space travel and quantum physics, like you do. These happen to be topics that we know next to nothing about, as is pretty much going to be a common theme with all of our talks, come to think of it. So that's how this particular topic came about. If you have something you want to hear us babble on about, then leave a comment below or tweet us using the hashtag ZaL Talks. We will find you. Enjoy.
Got this video, footage.
OBS recorder, man.
I'll set it up. I'll do it later. But fucking... So, the big problems with gravity is, one, you can't fly from the ISS to the Chinese space station because they're at any given point 15,000 miles apart or some ridiculous bullshit. I don't think it's exactly 15,000.
What they do, just jump from one to the other?
Yeah, they've got little air jetpacks, which are real.
Mm-hmm.
It's a thing actual astronauts have, is they can vent some of their O2 to give themselves some propulsion.
Yeah.
So they push off of the ISS, which is destroying itself and going to crash into Earth. And then they use their little jetpacks, and they fly over to the Chinese space station. Which you can't do. It's real far away. You're gonna die.
People don't understand how how big space is. People think, oh, if I had my own space shuttle, I'd just go to the moon, be back in time for tea. No, that shit takes 6 months to do. You don't understand. It takes 6 months to go to the moon.
No, it takes... Getting to the moon, I think, is only...
I heard it was 6 months.
It's... From launch to getting to the moon, I think, is only a few days.
Oh, okay. Because...
It takes us 8 months to get to Mars.
Oh, okay. So... Because, no, I heard it was... I was on that scale... no.
Let's find out some information.
Let's find out right now.
We have access to the internet.
Right meow.
To the moon. Take about 3 days. So I was right.
3 days. Okay. I was way off.
Yeah. So it takes about 3 days to get to the moon. And that's because in space... with no gravity and no air resistance, you travel real quick.
Mm-hmm.
Thousands of miles an hour quick.
Or, whatever you started off at, because there's nothing to slow you down.
It's not started off, you can adjust your acceleration through different propulsion means and stuff. But you can get to the moon pretty quick. So, but still... So, and just because we're talking about it and I have Google as...
So, question. If somehow we figured not light speed travel, but just under light speed travel, and then we shot something out of a gun, and so compared to us going almost light speed, it's now flying at Mach 1. Sure, why not? Compared to us.
Mm-hmm.
Does that mean we just invented faster than light travel?
So, that goes into the
whole... I know the whole theory is, once something reaches light speed, it bloats or it inflates or something.
What it is once you try to go past faster than light, your object that's traveling that speed, which means every atom in that, gains effectively mathematically infinite mass. So you can't go faster than that, because going faster than that turns every atom into a black hole, basically, and just destroys it. So you can't mathematically.
See, that makes about as much sense as what people used to think, where if you go above 50 miles an hour, your blood boils. That sounds something like that. I don't think that's real.
No, but see, when you go that fast, you start warping time. If you travel 90%...
Technically, you're warping time...
Theoretically, yeah. Like, gravity itself warps time. But no, like, if you travel around the Earth for 1 year, like, around the solar system for 1 year, going 99% the speed of light, when you come back to Earth, there's an equation for it, but it's something like 90-year span. You will have missed 90 years on Earth, but to you, only a year has passed. Because speed of light gets fucky. So when you get that fast, all of these different factors come into play. One, when you start going faster than the speed of light, things can't get out of the way in front of you fast enough. So you hit them. But you're going so fast that you don't just hit them, you fuse with them. And it just keeps going, but it's faster than the speed of light, so there's basically no time between it and the infinite mass. Because the faster you go, the heavier you get. We've already proven that. That's science. So the faster you go, the heavier you get. Now, it's not even air resistance. It's in a vacuum with nothing in it. Speed equals weight. Or speed equals mass, not weight. Because weight's relative.
Huh.
So, mathematically looking at it, the faster you go, the heavier you get. And if you go faster than the speed of light, which is the fastest we can think of, just exponentially grows to the point where it's virtually infinite mass. But there is this whole thing where if you go... There's this hypothesis that if you build a ship that can go 0.5 the speed of light, and that ship can also build a ship, or has a ship inside it, that can also go 0.5 the speed of light, does that mean that starting at 0.5 the speed of light and accelerating past that you could reach speed of light? Or does that mean...
Well, see, here's the thing, though.
Well, no, because when you start...
You would have to start accelerating while on the ship that's going...
No, that's what they're saying. Like, if you have a ship that contains another ship, so this ship is stationary and this ship is not, and this ship's going the speed of light, does this one's acceleration, would it compound, or would it just equal?
Well, I would assume it would compound.
But see, that's the thing.
That's the theory of relativity, because relative to the ship that's inside the ship,
this one's speed is 0.
Yeah,
and see, that's the question, because
it's like I imagine it would be like getting on one of those moving platforms at the airport. Like, you're walking the same speed you've always been walking, but now this is going this way faster.
No, see, the way to look at it as an example is Mythbusters had an episode on it, where if you shoot Mythbusters episode is if you shoot a cannonball backwards at 50 miles an hour while you're driving away from it at 50 miles an hour, does its speed become 0? Which, according to Mythbusters, it does.
Yeah.
Because its momentum cancels.
Yeah.
And same thing happens if you're going forward. If you are traveling a speed and then accelerate something that is also traveling that speed out, it gains that additional acceleration from the starting point. So they're saying, but this is because it involves quantum mechanics, and quantum mechanics is fucky, that if you take a ship that contains, if you take a sublight ship that can travel 1% of the speed of light, that contains a ship that can also travel 1% of the speed of light, you would add them together.
Yeah, that is generally how speed works. Yeah, that's why when you have two head-on collisions, they say, "Oh, it was a 60 mile an hour head-on collision." That means both of them were going 30 miles an hour.
No, see, that's not how that works. Because in that instance, momentum's conserved. If it's if you take a car going this way at 60 miles an hour and a car going this way at 60 miles an hour, they both stop hitting at 60 miles an hour. They don't add, because effectively they're both hitting a wall going 60.
Fair enough.
So the momentum isn't compounded on each other. The momentum goes into the crash itself.
Fair enough.
Yeah. So that's a different... That's looking at it differently.
But yeah, it's like you said, quantum mechanics is really, really fucky.
Yeah, so there's nothing saying... Because we can't try it, we can't prove it, we can just talk about it.
Yeah.
And
we're really good at talking about it. we can put shit on paper all day long.
So that's where a lot of that stuff comes from, is if we talk, we can talk about it, and we can say, theoretically, because that's all you can say is theoretically, because we have no way to put it in practice, that if you take two sublight ships and launch one of them from the other, you would add this the previous momentum, thus gaining a higher speed of light than previously achieved. So theoretically, if you could make ships that could make ships that could also make ships...
It's just ships all the way down.
Yeah, if you just did ships all the way down, you could eventually make a ship that could transport people, and you would just have like a line of ships going from Earth to, say, Alpha Centauri, which is the closest galaxy that we think probably has people.
What about Andromeda's?
Oh, no, Alpha Centauri is...
Andromeda's is literally on a collision course for us. I'd say that's...
No, Alpha Centauri is not... It's... Alpha Centauri is a planet or something. Let me get this straight. I forgot what Alpha Centauri is.
To Google!
Yeah. Alpha Centauri. Star system. That's what it was. It's not galaxy, star system. So Alpha Centauri is like a star system that is the closest cluster of planets around a star, similar to our own.
Yeah.
If we could build a ship that could build ships that could build ships, that each one, say... I have no idea. I haven't even been in the kitchen. So if we build ships that can all go...
You act like I do dishes.
You're right.
That all go the percent of speed of light, then theoretically it takes 4 light years to get to Alpha Centauri, but we could get there in, like, say, 10. Because just exponentially, if it takes us 14 ships, we'd be... And each ship can go 1% the speed of light. Eventually, we'd hit 14% the speed of light and get there. We would just have 14 ships traveling at the speed of light on a collision course for Alpha Centauri. Not that it would hit anything. It's a solar system.
Yeah, well, I mean, technically you would hit the solar system.
Yeah, you probably won't hit anything in the solar system. But yeah, so...
I don't know. The odds of successfully navigating an asteroid field are...
pretty good.
Yeah, considering they're literally miles apart.
Yeah, I mean, it's not like Star Wars wants you to believe. It's not that, but now micrometeors or microcomets, those are what get you.
Which are literally just space pebbles.
Yeah, space pebbles that will go through your entire ship because they're traveling at tens of thousands of miles an hour.
That's what really killed the dinosaurs.
No, that's what's fucking up the ISS right now. Like, they have a huge problem with the space dust.
Yeah,
the technical term, because it just helps the ship constantly.
And that was pretty much the entire conversation. We appreciate you guys listening, and if there's anything you want to hear us talk about, again, either leave a comment below or tweet us using the hashtag ZaL Talks. ZaLTalks.